Hi everyone, let's solve this problem. Kth largest element in an array. Given an integer array nums and integer k, return the kth largest element in an array. Note that it is the kth largest element in the sorted order, not the kth distinct element. That means if there are duplicates, we have to so in this case, if we just sort this particular array, I have 1, 2, 2, 3, 3, 4, 5, 5, 6. So this is the sorted one, and we want to get the fourth largest. 1, 2, 3, 4. Fourth largest is 4. So we don't have to have the unique elements. That's what they are saying. And also, can you solve it without sorting? So basically they don't want us to sort the array. Now let's use heap solution to understand this problem. So let me just copy an example from here, and for this, since we have to find the max value, let's consider taking a max heap. So I'll just keep inserting all the elements 3, 2, 1, 5, 6 and 4. The size of the heap is n. So all the insertions would be n into log n. Now for k times I have to fetch the element. So k equal to 1, I'll fetch 6. So this will be deleted from the heap, but this is not our answer. Then I'll again erase one of it and I'll get it 5. 5 will be my answer, and this will be k into log n, because log n is the size of the n is the size of the heap. Now let's see if we can solve it using min heap and in much better time complexity. So this is the time complexity of max heap, just for reference. Now I have a min heap. I get 3, I insert, and we are going to ensure that the size of the heap is just 2. Okay, let me write it as size is 2. And I get 2, I insert into the heap. Now when I get 1, so let's say 1, 2, 3, 3 elements are there, and these 2 elements are already present inside the heap. Do you think this number will be matter? It will not matter, because the k size is 2 and we already have 2 greater elements. So how are we going to compare that? That we can compare based on, if I am getting a number, if it is less than the current min element. From min heap, when we fetch, we'll get 2, right? So if it is less than that, that means this number is not even required inside the heap, right? So we can just ignore that particular number. Then we move ahead, and then 5. So when I get 5 greater than 2, that means I have to insert 5. Then if 5 and 3 are present, second largest element will be 3, right? So I have to remove the min element from here. Then when I get 6, again same thing, 6 is greater than 3, so I will be deleting this 3 and inserting 6. Then I move to 4. Now 4 is less than 5, right? 4 is less than 5. That means we are not going to insert this element into the heap. And now, since it's a min heap, we already have minimum element on the top. So if we just fetch, it will be just 5, right? So this will take n log k time. For every element we are going to insert k times. So it is log k, and the size of the heap is k. And for every k also we are not going to fetch. It is just big of one time, because first, or basically log k we can write, because we are just fetching the first element. So even for fetching, delete and fetch will take log k, but if you're just fetching the top element, like peeking into that, it will just take big of one time, so we don't have to even delete that element, so it will be just one. So overall time complexity will be n log k, and the space complexity would be k. Here the space complexity was n. So now let's try to write the code for this. So let min heap and for every number, first if min heap dot size is less than k, we can directly insert the element into the min heap. Else if I'm going to check the min heap friend, which is nothing but the minimum element in that heap, if it is greater than number, we have to insert into the heap, right? If number is greater than the minimum element on the heap, then we are going to first delete one of the elements and then insert our element. And at least one number will be there, so heap will not be empty. So in this case we can just return min heap dot friend. So that should be good enough. Let's run this. Let's submit it. And also the time complexity of this solution as discussed is in this particular thing, it's n log k comma k. Okay, and space complexity is k. I hope the solution is clear. Thank you.